In this video, I want to look at what's known as the central limit theorem. Let's suppose I have some random variable. I know the mean is mu and the variance is sigma squared. We also need a sample of size n. We need our sample to be large enough, and for our purposes, greater than or equal to 30 will be large enough, so we need a sample size of 30 or bigger. Then x bar has approximately a normal distribution where x bar is the random variable given by the mean of samples of size n. The mean of x bar is going to be mu, and the variance is given by the original variance divided by the square root of the sample size. So let's look at an example of this. Let's suppose the level of impurity in a randomly selected batch of chemicals is a random variable with mean 4.0% and standard deviation 1.5%. For a random sample of 50 batches, we want to find approximation to the probability that the average level of impurity is between 3.5 and 3.8%. So we want the probability that x bar is between 3.5 and 3.8, and we know we're using x bar rather than x because I do have a sample size of 50. Because I have a sample size, I'm using the central limit theorem. That tells me my mean is the same. My variance was the original variance over the sample size. So my standard deviation would be the original standard deviation over the square root of the sample size, since we just need to take the square root of this. In R, we need to use the command pnorm. We have the first probability, the mean, and the standard deviation. And then we subtract out the lower probability. 3.5, the mean is 4, and the standard deviation 1.5 over the square root of 50. So this command in R would give us this proportion and this probability. Next, let's suppose we want to find an approximation to the 95th percentile of the average impurity level. My mean is still 4, and my standard deviation was the original standard deviation over the square root of the sample size, according to the central limit theorem. For percentiles, we're going to use qnorm. We're looking for the 95th percentile. My mean is 4. My standard deviation, 1.5 over the square root of 50. So this command in R would give me the solution here.